Dr. James Patterson had 23 years of experience with the National Oceanic and Atmospheric Administration, specialized in tropical cyclone forecasting, and had access to the most sophisticated weather prediction technology in the world: satellite imagery, computer models, Doppler radar systems, ocean buoys, measuring temperature and pressure in real time. When he arrived in the Philippines as part of a disaster preparedness training program, he brought absolute confidence in modern meteorological science. During a community meeting in a coastal fishing village in eastern Samar, the local disaster coordinator introduced Mang Tomas, an elderly fisherman who'd lived through 60 typhoons and served as the village's traditional weather observer. Mang Tomas can often predict storm behavior days before our equipment shows changes, the coordinator explained. His methods have been passed down for generations. James smiled politely. The way scientists do when encountering folk wisdom they know to be superstition. That's fascinating cultural knowledge, certainly. But modern meteorology uses satellite data, atmospheric models, and real-time ocean measurements. We can track storms from formation to landfall with precision that human observation simply can't match. Mang Tomas, who understood more English than he spoke, nodded respectfully but said something in Tagalog to the coordinator. The coordinator translated. Mang Tomas says the signs show a very dangerous storm coming in 3 days, worse than the models predict. He recommends evacuating the coastal barangays. Now, James pulled up his tablet, showing the latest satellite imagery and model outputs. According to NOAA data, we have a tropical depression forming east of Guam. Current models predict it will strengthen to a tropical storm, possibly a weak typhoon, but not reach this area for at least 6 days if it maintains current trajectory. There's no indication of rapid intensification or deviation toward this region. I appreciate Mang Tomas's concern, but the science doesn't support immediate evacuation. The coordinator looked uncomfortable. Dr. Patterson Mang Tomas has been right before when the models were wrong. His signs, James interrupted gently but firmly. I understand there's cultural attachment to traditional methods, but we're talking about evacuating thousands of people, disrupting livelihoods, causing economic impact. We can't make those decisions based on observation of clouds or wave patterns or whatever traditional signs are being used. We make them based on data, models, science. The storm is 6 days out, if it even comes this direction, which current projections say is unlikely. We have time. What James didn't understand was that Mang Tomas wasn't just observing clouds. His knowledge represented generations of Filipino fishermen studying typhoon behavior in these specific waters, learning to read signs that satellites couldn't measure, the color and behavior of certain fish species that dove deep before storms, the flight patterns of seabirds that sensed pressure changes, the smell of the wind carrying moisture patterns from hundreds of kilometers away, the behavior of waves that indicated deep ocean currents shifting, the appearance of specific cloud formations at sunset that meant rapid intensification. These weren't superstitions. They were observational data points, refined over centuries by people whose survival depended on reading weather correctly. That evening, Mang Tomas took his boat out briefly, against James's recommendation about safety. He observed things that bothered him deeply. The ocean temperature felt wrong. The wave patterns indicated unusual current behavior. The birds were already moving inland earlier than normal, and the sunset showed cloud formations he'd only seen twice before, both times preceding catastrophic typhoons. He returned and spoke urgently to the coordinator. The coordinator called James. Dr. Patterson, Mang Tomas is very concerned. He's seeing multiple signs he associates with rapidly intensifying super typhoons. He's asking again about evacuation. James checked his latest data. The tropical depression had strengthened slightly to a tropical storm, but models still showed it tracking north of the Philippines, weakening over cooler waters. The models haven't changed. Storm is still projected to pass north of your location. Current intensity is 65 kilometers per hour, forecast to reach maybe 110 at peak. That's a weak typhoon, not a super typhoon. Mang Tomas's traditional signs might be reliable for general weather, but they can't predict specific storm intensification or track changes. That requires meteorological instruments and computer modeling. Please tell him I appreciate his concern, but the science says we're safe. The coordinator hesitated. Dr. Patterson Mang Tomas wants to evacuate his village tomorrow morning anyway, with or without official orders. He says the signs are too strong to ignore. James felt frustration rising. This was exactly why traditional knowledge, however culturally important, couldn't replace scientific forecasting. One fisherman's interpretation of natural signs causing panic and unnecessary evacuation. That's his choice. But I can't recommend official evacuation based on traditional observation when all scientific data says it's unnecessary. If we evacuate every time someone observes unusual bird behavior, we'd never keep people in their homes. The next morning, Mang Tomas and about 40 families from his immediate community evacuated to the inland evacuation center, carrying what they could. Other villagers, following official guidance based on James's assessment, stayed. James filed his daily report, storm tracking as predicted, no threat to eastern Samar, situation normal. But that afternoon, something unprecedented happened. The tropical storm, now named Typhoon Rosario, suddenly deviated from its predicted track. It turned sharply southwest directly, toward the Philippines, and it began intensifying rapidly in a way the models hadn't predicted. By evening, Rosario was a Category 3 typhoon with winds of 195 km per hour, and still strengthening. James watched in growing horror as every model run showed the same thing. Rosario would make landfall near eastern Samar in approximately 36 hours as a Category 5 super typhoon. The rapid intensification was occurring over an ocean-warm pool that the satellite data had inadequately measured. The track deviation was driven by an upper-level wind pattern that the models had failed to predict. Everything Mang Tomas had warned about was happening, and James had dismissed it. Emergency evacuation orders went out immediately, but now they had barely a day instead of the 3 days Mang Tomas had recommended. Roads became clogged. Some coastal communities couldn't evacuate in time. James worked frantically with local officials, but he kept thinking about Mang Tomas's village already evacuated, already safe, because an elderly fisherman had read signs that billion-dollar satellites had missed. Typhoon Rosario made landfall as one of the strongest storms ever recorded in that region, sustained winds of 315 km per hour, storm surge of 7 meters, catastrophic devastation. The evacuation centers inland were overwhelmed. Thousands had evacuated at the last minute, cramming into facilities designed for hundreds. But Mang Tomas's group, having evacuated 2 days earlier, had secured good shelter positions and had time to properly prepare. When James reached the evacuation center, where Mang Tomas was sheltering, he found the old fisherman calmly helping organize supplies, having known this was coming all along. "Mang Tomas," James said, his voice hoarse from exhaustion and shame, "you were right about everything. The intensity, the timing, the track, my models, $1 billion of equipment, and you predicted this storm's behavior 3 days before any of it showed up on our satellites." "How?" "Through the coordinator," Mang Tomas explained patiently. He'd noticed unusual fish behavior 5 days ago, specific deep-water species appearing in shallow waters, indicating they were fleeing unusual ocean conditions. The seabirds had shown panic behavior, abandoning nesting sites earlier than normal. The waves had a specific pattern he'd learned to associate with massive storms forming beyond the horizon, a deep ocean swell pattern that preceded super typhoons. The wind had carried a moisture smell that indicated the storm was pulling water from hundreds of kilometers away, and the sunset clouds had shown the specific formation his grandfather had taught him meant rapid intensification, a sign that had never been wrong in 60 years of observation. "Dr. Patterson," Mang Tomas said through the translator, "your machines see many things. Temperature, pressure, wind, from space, very powerful, but they do not see everything. They do not see how fish behave, how birds feel pressure, how ocean smells, how waves move in deep water. My people, we watch these signs for hundreds of years. We learn which signs mean danger, which signs lie, which signs tell truth. Different knowledge than your science, but not less knowledge. The ocean teaches us what satellites cannot see." James spent the next week helping with disaster response, but he also spent it learning from Mang Tomas. He documented every traditional weather sign the fishermen used, the fish behaviors, the bird patterns, the wave characteristics, the wind smells, the cloud formations. He recorded which signs predicted what outcomes, how Mang Tomas weighted different observations, how generations of fishermen had refined this predictive system through trial, error, and tragedy. When he returned to the United States, James did something that risked his professional reputation. He published a paper titled "Traditional Weather Prediction in Philippine Fishing Communities: Observational Data Points Missed by Modern Meteorological Instruments." He detailed how Mang Tomas had predicted Typhoon Rosario's behavior days before satellite data showed the changes, and he argued that traditional observation systems weren't superstition, they were systematic observation of atmospheric and oceanic phenomena that modern instruments didn't adequately measure. He proposed integrating traditional weather observers into official forecasting systems, not as replacements for technology but as complementary data sources. The paper was controversial. Some colleagues accused him of undermining scientific meteorology, but others, particularly those who'd worked in indigenous communities, recognized something important: that local observational knowledge, refined over generations, sometimes captured atmospheric phenomena that satellites missed. Within 3 years, the Philippine Atmospheric, Geophysical, and Astronomical Services Administration (PAGASA) had established a pilot program integrating traditional weather observers like Mang Tomas into their forecasting system. When satellites and models showed one thing but traditional observers reported contradictory signs, forecasters now had protocols to investigate further, rather than automatically dismissing traditional knowledge. The program proved its worth during Typhoon Santos 2 years later. Satellite data suggested the storm would weaken. Traditional observers along the coast reported signs indicating rapid intensification. PAGASA forecasters, remembering Rosario, issued stronger warnings based on the traditional observations. Santos did intensify rapidly, but communities were prepared because someone had listened to the fishermen reading the ocean's warnings. James returned to the Philippines regularly, now working with Mang Tomas and other traditional weather observers to document their knowledge before it was lost to younger generations who relied solely on smartphones and apps. They created a training program teaching young Filipinos how to read traditional weather signs alongside modern meteorology, and James kept a photo on his desk: Mang Tomas standing on the beach, pointing at cloud formations, teaching an American meteorologist with 23 years of experience how to read the sky the way his ancestors had for centuries. Below it, a quote: James wrote himself, "I came to the Philippines with satellites, models, and PhD-level confidence that modern science had made traditional knowledge obsolete. Then, an elderly fisherman predicted a super typhoon 3 days before my billion-dollar equipment saw it coming, and saved thousands of lives I'd told them they didn't need to worry about." The most advanced weather forecasting doesn't come from choosing science or traditional knowledge. It comes from being humble enough to integrate both, because the ocean speaks in languages satellites haven't learned to hear, and the people who've listened to it for generations might know something that our instruments missed.